Hey, this is Joe, and today let's talk about the quotient rule for exponents. The quotient rule for exponents deals with any situation where we have a variable raised to a power divided by the same variable raised to another power. And right here we have x to the m power divided by x to the n power, and that's going to be equal to x to the m minus n power. In other words, we take the top power and we subtract the bottom power from it. Now let's find where this rule comes from. Let's look at this example, x raised to the third power divided by x raised to the second power. Looking at the numerator, x to the third power, we could rewrite that as x times itself 3 times. In the denominator, we have x to the second power, which we can rewrite as x times itself twice. And what we can do is kind of pair one x on the top with one x on the bottom, and we end up getting this next line here where we get x over x times x over x times x. Now, x over x is equal to 1, and so we can replace both of these with 1. In other words, we have 1 times x. And anything times 1 is equal to itself, so we're left with just x. So we get x to the third power divided by x to the second power equals x. And instead of writing out all these x's and then finding how many 1s there are, we can end up just using this property instead as a shortcut. That is, if we use this property for this problem, we would have x to the third power divided by x to the second power is equal to x to the 3 minus 2 power, which is equal to x to the 1 power, which is just x. So let's work with a few more examples. Let's look at x to the 6th power divided by x to the third power. Using this property, we can rewrite this as x to the 6 minus 3 power, and since 6 minus 3 is 3, we get x to the third power. And so, as you can see, we can kind of jump straight to our answer. Now, let's look at x to the second power divided by x to the 7th power. Well, this is going to be x to the 2 minus 7 power, which is going to give us x to the negative 5 power. And remember, anytime we have a negative power, we can move it up or down to make it positive. So since we have a negative power in our numerator, we could use this rule here and rewrite it as 1 over x to the 5 power. And if you forget that rule, you can check out this video here. But notice, why did this happen here? Well, anytime the power in the denominator is bigger than the power in the numerator, we're going to have this negative power whenever we do this subtraction. So we could kind of rewrite this rule in two cases, where if my power in the numerator is larger than the power in the denominator, I can use the rule as I stated to begin with. But if I have the denominator power being larger than the numerator power, or n greater than m, I could rewrite this as 1 over x to the n minus m power. So let's simplify one more expression that allows us to use these two rules. Let's consider this example here. And since everything is multiplied together, we can use the property introduced in this video in order to simplify this. In other words, let's just look at our powers of x in the numerator and the denominator. It looks like we have x to the 4th over x to the 3rd, and that would fall into the category where the power in the numerator is larger than the power in the denominator, so we'll use this first rule, and that's going to give us x to the 4 minus 3 in the numerator, and since 4 minus 3 is 1, we just get x to the 1 power. Next, let's look at y. We have y to the 2nd over y to the 5. Since 5 is larger than 2, and y to the 5 is in the denominator, we can use the second form of this rule, which tells us that we're going to put y in the denominator, and its power is going to be the n minus m value. Since n is 5 and m is 2 here, I'm going to have 5 minus 2, which is going to give us 3. If we look at z here, we have no power in the denominator of z, and so we can't do anything, so we'll just bring that over in the numerator as it is. Finally, looking at j, we have j to the 1st over j to the 6th. Since 6 is greater than 1, we're going to use the second form of the rule, which is going to tell us to put j in the denominator and raise it to the n minus m power, which is going to be 6 minus 1 here, which will give us j to the 5th power. Now, in each one of our problems, we never had addition or subtraction within the numerator and the denominator. And so if you have addition or subtraction in between your variables in the numerator and the denominator, you have to be careful. In other words, consider this problem here where I have x squared plus y all divided by x times y to the 2nd power. And we could potentially make a mistake here where we just say, all right, x to the second is greater than x to the 1, so I have x to the 2 minus 1 in the numerator, which will give me x. I have a larger power of y in the denominator. It's going to be 2 minus 1, so I'm going to get y in the denominator, and I'm done. But you have to be careful of this operation that's in the numerator. Sometimes, when you have plus or minus in the numerator, you have to break your fraction apart into independent fractions. That is, we take x squared and divide it by x times y to the second, and then we add y over x times y to the second. We split up the two terms and treat them as their own individual fractions, and then within those we can use the rules, and we get x over y squared for our first term, and we get 1 over xy for our second term. So we have this answer here. And if you're confused about how you break apart fractions, you could always reach out to your teacher for some advice or whoever you're working with. I'm Joe, and thanks for spending some time with me.